here to talk about the work of my research group, Visual Geometry Group, or VGG. I'm delighted to see got a mention on one of Susanna's slides, and this talk is going to be an overview of a program in computer vision, particularly AI-based computer vision, rather than a specific project talk, but I hope to foreground some of our collaborators in this talk as well, and some of them indeed are in this room prominently. Neil from the British Library, who knows our work very well. Okay, so this is us. We're a large general purpose computer vision research group. We are increasingly working on audiovisual materials and sometimes text as well. We have a number of project ambassadors, including me. My job title is Digital Humanities Ambassador, and there's another ambassador in life sciences, or maybe others soon in other fields. And our job is engagement and supports and community building. It says in my job description, to disseminate VGG research to appropriate communities and to uncover research questions, interesting data sets, feature requests, etc. What do we do for LAM? We offer training and support. I particularly spend a lot of time doing training and talking to people about what we offer. We do more in-depth research collaboration. The research could be at the technical end, or it could be at the end of collections or humanities scholarship. We do rather more focused implementations and demos than many pure research groups do. We think it's important to get our methods out in the world, if you like, perhaps because, I don't think I mentioned this, but we're based in the Department of Engineering Science at the University of Oxford. So as an engineering group, we're very interested in building end-to-end working solutions. We spend a lot of time creating data sets and co-curating them with partners. And I think I just want to dwell on this point, because I think probably pretty much everyone on this call will be aware that arts and humanities, libraries, galleries and museums, people who have large data are of great interest to AI research groups and tech firms, because that's where the data is, right? Not just that's where the data is in bulk, but it's also well characterized, it has good provenance, has good descriptions. It may not be incomplete, and if you're a collection manager, you may wish you had more descriptions, but certainly compared to material that you can scrape from Flickr, it has genuine value for people like ourselves and the large cloud AI providers as well. So if you're in the position of being wooed by one of those people, one of those organizations, includes ourselves, I urge you to kind of recognize that value and to strike a bargain that works for your institution accordingly. Much of these activities lately, particularly under our current grants, and actually our next grant, which runs until 2025, are organized around software. So lately we've been moving on from academic toolkits based on things like MATLAB. People who work in research software engineering and may know things like VLFeats and MatConvNet. We still produce these kinds of research software, but we also increasingly produce modular software that's aimed to be deployable much more widely than these toolkits. And you can see just by the names alone, it's kind of much more descriptive names that intention perhaps. Okay, so I'm going to move on now to some case studies of what we've done with, not just with this software, but actually in order to build out this software. So here is something we did in 2014, a collaboration with the organisation now known as Art UK, formerly Your Paintings. It was called Your Paintings because it was originally based on paintings in public ownership in the United Kingdom, oil paintings. And what we did with this was build a toolchain for on-the-fly CNN training and a user interface through which you could query the data on the fly using tagged images downloaded from Google. So you can see in the schematic in the top left-hand corner, a keyword search on Google has triggered some results, some labeled images, which are then applied to the data set, the Art UK data set, and we have some negative instances down by the bottom. And what that retrieves is, importantly, in this case, it's artworks, right? It's not photographs, but it's recognizably men with beards. And, you know, this tool does the kind of usual range of object classification tasks, simple object classification. So boats, it can pretty well recognize what a boat is. Perhaps more suggestively, it can also recognize certain defined textures. So Cobweb is enabling a kind of serendipitous, almost similarity-based search, although similarity is, of course, a complex term and one we tend to use quite judiciously. Color as well similarly supports this kind of browsing ability. I mean, these things are kind of well and good and kind of well established in several implementations, but I would suggest, particularly for this community, that the way forward is to do compounds search, compound classifications, and leading towards a kind of more high-level iconographic deconstruction of an image. So, for example, in the Western art tradition, we know that we're looking at a painting of the Nativity because it always has a woman and child, I guess, and sometimes may have one of several elements such as angels, shepherds, a desert scene, and so on and so forth. It seems to me that this is really the kind of the next phase in this kind of tagging, to kind of work with kind of real relational, hierarchical, contextual metadata. And again, this is another reason why computer vision groups like ourselves, like AI groups, like working with museums, because of the complex nature of the metadata, as well as the rich, the unusually broad and deep range of the images themselves. Okay, so it's image classification. We're in the situation, having been around for a while, of having predated the current AI boom. In fact, I've seen several AI booms come and go. I'd just like to kind of foreground methods that perhaps aren't now considered to be AI, but are still very performant for particular tasks. So this was the state of the art circa 2008, 2010 for so-called instance-based image recognition and retrieving the exact same geometric assembly of features, in this case a building in Oxford, which we used through a combination of SIFT features, an algorithm that's just actually, as of only a few months ago, come out of patent, on top of which we use a bag of visual words algorithm, a sort of topic modeling in a sense, one of many features that many techniques that image people borrow from linguistics. And this turns out to work pretty well for all sorts of cultural materials, particularly illustrations in printed books. And we have a couple of online demos that show this, accurately retrieving impressions of the same printing surface. There's some variation in shading and coloring on the right, but the geometry remains, so we can match that. And pages are pretty flat as well in most cases, which helps. We also have instance-based image recognition built into a tool we have online on what's on the now iconic BL1M, the British Library's million images from the 19th century books, which they put on Flickr. In audiovisual content, it also works on, for example, the Google logo here, which is used both here as canned footage, but also in various contexts just at the bottom of the screen. This tool is kind of worth I think explaining a bit, because as you can see in the top, it has 4 search modalities. So it's our kind of, if you like, our flagship demo. We can search by instances, by objects and scenes using deep nets. We also have a text spotter, so we can read Google as well, and we have facial recognition built in. So there's a, sorry, the slide's got a little bit mangled. There's an overview of what's in the resource. And for those interested, some stats on how long it took. These slides are now out of date, I have to admit, because the demo has just been rebuilt, but this is as of about 3 years ago, processing time and other stats to build this demo. That may be of interest to some. Staying with video, we've lately been working in the British Library's Broadcast News Collaboration, which is an archive that records records and makes available 23 TV channels and numerous radio channels available over the air in the United Kingdom. So not just the BBC, but also commercial broadcasters, Al Jazeera, Russia Today, and so on and so forth. And we recently came a runner-up in a BL Labs competition to work with BL data, in which we aim to identify people in, the test case was BBC News, but we're going on to other data sets lately, which we did through a combination of facial recognition. And I very much support what Zuzana says about the kind of imprecise performance of facial recognition. We kind of quote unquote cheated, if you like, or rather used all aspects of the data, which I think is a valuable thing, because we also use text, so we use the captions to aid in the recognition, and we also use speaker identification. So we align the audio stream with movement of lips if it was in shot, and use that to kind of boost the recognition. We're well aware, of course, that there are profound ethical and privacy problems with facial recognition, particularly around bias, ethnic and gender bias. We have done some work to address this, both through the production of better data sets, but also through methods. My colleague Christoph Nelliker, who's my counterpart ambassador in life sciences, has been particularly leading on this, in part due to his work on facial recognition to recognize not identities, but actually illnesses that present facially. So the bias issue there particularly fraught. For the future, we currently employ 3 full-time research software engineers funded by the Engineering and Physical Science Research Council in the UK until the end of next month, but then another grant seamlessly takes over and takes us up until 2025. All the tools I've shown today are free and open source under BSD license. We have Docker files for many of them, as well as, of course, compilable code. Native binaries are coming soon for Vice, our instance-based search engine, which initially Windows, then Mac. And this is in the spirit of, like I say, trying to kind of push our tools out more widely. A particular interest for this community, I think, will be that we're starting to support IIIF. So at the stage of ingest, in some of our tools, it's possible to specify a manifest instead of a bunch of files as local storage. Those images then get ingested and displayed. This is the front end for our classifier tool, VIC. And if you click on an individual tool, you can see that we've been able to retrieve, of course, the metadata along with the image, and in many cases a link back to that image in the native repository, depending on how that's been formed within the manifest. Okay, and this is a use case that I particularly relish, coming as I do from background in early printed books. It seems to me that a great use case for the combination of IIIF and computer vision would be matching slightly different images, in this case prints. So here we've got some variations both in engraving and in letterpress text. In Shakespeare's First Folio, many institutions have digitized their First Folio. One can certainly imagine a IIIF-based comparison tool working across those institutions. Here are some links, including the slides, which I'll put in the chat and in the Google Doc. And I'll invite questions at the end, I think. Thank you.
Are the systems you're running really designed and meant to be running in your labs or your institutions, or are they portable software? Or what are the best ways for others outside of your networks to take advantage of the good work you've done?
In my case, Tom, I think the best way for people to take advantage of the tools I've shown is to download and play with them. Like I say, that the hope is to make them usable outside of the lab. It's remarkable how little AI software in general, particularly in vision apps, is available on the desktop. There's of course lots is available through the cloud, and that's lots of people's point of entry to it. Institutions may be a little wary of uploading images to the cloud in some cases to be processed on, and that may be an attraction of the downloadable binaries and code we make available. But I definitely encourage people to experiment, play, critique is really important, contribute if they can, which isn't something I had enough play, I think, in my talk, and to build and give us feedback.